Hello friends, today we are going to learn about digital circuits which are used to add two binary number. Addition of two binary digits is most basic operation performed by digital computer with the help of circuit called as adder. So there are two types of adder. First is half adder and second is full adder. Half adder is combinational circuit where output is depend upon only present state of input. It can perform addition of only two single bit number. There is no provision to carry which is coming from LSB side. So this is one disadvantage of half adder, and to overcome this disadvantage we can use full adder. Full adder is again one combinational circuit. It can perform addition of two single bit number along with carry which is coming from LSB side. So it can overcome disadvantage of half adder. So in this section, with the help of truth table and K-map structure, we will figure it out circuit diagram for half adder and full adder circuit. Figure A shows block diagram of half adder. Half adder has two input A and B and two outputs sum and carry, which is basic building block of addition of two single bit number. Table B shows truth table of half adder. As there are two input A and B, we have to use total 4 possible input combination like 0 0 0 1 1 0 and 1 1. In output section we have two outputs sum and carry. So in this table here we have used simple rule of binary addition. When we add 0 plus 0, we'll get sum is 0 and carry is also 0. When we'll add 0 plus 1, we'll get sum is 1 and carry is 0. When A is equal to 1, B is equal to 0, after addition we'll get sum is equal to 1 and carry is equal to 1, and at last when A and B both are 1 1, we'll get sum is 0 and carry is 1. So this is truth table of half adder. Now just consider one example of half adder. When A is having single bit number 1, B is having single bit number 1. When we'll perform addition of these two number 1 1, we'll get result 1 0, because when we'll add 1 plus 1, we'll get sum as a 0 and 1 is a carry. In next example, when A is having two single bit number 1 1 and B is having again two numbers 0 1. So when we'll add this 1 1, we'll get 0 as a sum, and after that one carry will get created. Here we have to use add this carry to this number. So when we'll add 1 plus 0 plus 1, here we cannot perform this addition, because in case of half adder we can only perform addition of two single bit number. We cannot consider carry which is coming from LSB side. So for this reason we need to use full adder. This is disadvantage of half adder which can overcome by full adder. Full adder we'll discuss in next section. Figure it out circuit diagram for half adder. So in figure C and D, it shows K-map for carry and sum. Here we need to consider truth table of half adder. Consider figure C. In truth table, in carry column, we have 1 only when A is equal to 1 and B is equal to 1. We just have to consider entries of 1. Need to circle this single 1. So from this K-map, we'll get equation for carry is A dot B. That dot represent AND gate. In figure D, consider truth table of half adder and consider entries of column sum. We have 1 when A is equal to 0 and B is equal to 1. Again we have 1 when A is equal to 1 and B is equal to 0. So here we cannot form any pair or chord. So we'll circle this single one. From this K-map, we'll get equation for sum is A B naught plus A naught B. So collectively this equation is called as A XOR B. Figure E shows circuit diagram of half adder. The equation of carry is A dot B. It means there is AND gate in between input variable A and B. So here we have used one AND gate in between input variable A and B, and the equation for sum is A XOR B. So here we have used one XOR gate in between input variable A and B, and from output of XOR gate we'll check sum, and from output of AND gate will check carry. So this is required circuit diagram of half adder which will perform addition of two single bit numbers. Now next topic is full adder. Figure F shows the block diagram of full adder. In case of full adder, there are total 3 inputs A, B and C in. C in stand for carry input and two outputs sum and carry. Full adder is basic building block of addition of two single bit number along with carry which is coming from LSB side. Now table G shows truth table of full adder. So as there are 3 input, total here we have used total 8 possible input combination starting from 0 0 0 0 0 1 up to 1 1 1, and in case of output there are two output carry and sum. Here also we have used basic rule of binary addition. So when we add 0 plus 0 plus 0 we will get sum as a 0 and carry is also 0. Just consider one example. If A is having two bits 1 1 and B is having two bits 0 1, when we'll perform addition of this number 1 plus 1 starting from LSB side, 1 plus 1 will get sum as a 0 and we'll get 1 as a carry. So what we'll do, we'll add this carry to the next bits. So moving toward MSB side, now next bits are 1 plus 0 plus 1. When we'll add this number, we'll get 0 as a sum and 1 as a carry. So we can perform addition of two single bit number along with carry which is coming from LSB side with the help of full adder. Now in figure H and I, we shows K-map for carry and sum. In figure H, this K-map represent carry. So as there are 3 inputs, we have used 3 variable K-map structure, and here also we have used same method like truth table of half adder, and we place 1 as per respective cell in K-map, and here we got 3 pairs. So from this pair we have equation AB plus AC in plus BC in. A, B and C in, these are 3 inputs. In figure I, this K-map shows this K-map is for sum, and as per entries in truth table, here we have 4 1 circle, so here we cannot form any pair or chord. So for this reason this equation for sum is A XOR B XOR C. After solving this equation we'll get A XOR B XOR C. Figure J shows circuit diagram of full adder. As there are 3 input A, B, C in, and the equation of sum is A XOR B XOR C in. So here we have used one XOR gate, and from output of XOR gate we can check sum. Likewise, the equation of carry is AB plus AC in plus BC in. So in between input variable AB, AC and BC in, there is AND gate. So total here we have used 3 AND gate, and in between input variable AB, AC in and BC in, plus sign is used. So plus sign indicate that we have to use here one OR gate. So output of every AND gate is connected to input of OR gate. So from output of OR gate we can check carry. So this is required circuit diagram for full adder which is responsible to perform operation of two single bit number along with carry which is coming from LSB side.